Hello and welcome everyone, this is Dmitry and this is another network programmability stream. As always, I'm very excited to be here with you today. The topic of today's stream will be containers and how to convert Python application into Docker and why would you want to do it in the first place, and basically all the stuff that is related to containers, Docker and Python in Docker. So we didn't have a stream for 2 weeks. Well, already 3 weeks, but we just missed 2 streams. And the reason why is that I had a vacation and I decided that I will not do anything that is somehow related to what I usually do, like writing code and all that stuff. So I decided to take a break and cancel the stream. I actually canceled 2 streams during my vacation so that I have some time off from all of the technology stuff. But now we are back and I hope we should be on schedule. I also do not have any trips planned in the nearest future, so that means that unless there will happen something, I think we should be able on schedule for every week. Since we didn't have streams for 3 weeks now, I do have a lot of interesting news and things that I want to share with you, and I will get to them in a moment. Before doing that, I also just have to let you know that probably today's stream is going to be shorter than usual, so probably not 3 hours, but something around like 2 hours or 2 hours 30 minutes. We'll see how it goes. The main reason for that is since I'm studying for Georgia Tech, I usually every so often have to finish my homeworks and stuff and submit it until deadline. So today is the day. Let's jump right into the news for today's stream. So the first one. The first piece of news is that Cisco NSO is now free for evaluation, so you can download the binary for NSO and install it for free. The net packages this is something that is additional. They are not free as before, but there are some net packages that come with NSO together with installation, and that should be enough for you to get started and to understand how NSO works and to understand if you will get any value from running it in your network. Hint, we did have a stream before on Cisco NSO, actually a couple of streams, and I did find it very, very interesting project, very interesting application, and I do encourage you now that it's free. There is, nothing could stop you from doing that, from trying it out. So if you just type in Google Cisco NSO, you'll land up on this page, and there's somewhere NSO is now free to download for non-production use. So if you click here, it will lead you to the another page with documentation for that. And on the left hand side you can download it for Mac and for Linux. Go ahead and try it if you are interested in doing network automation. I do think that NSO architecture is very interesting compared to some other network automation systems out there. We had the streams, so also make sure you check out the recording for those streams. Now another thing that I discovered recently is Sentry, and this project is Sentry.io, and God, I honestly think this is just great. So the idea behind it, and I don't think I will be able to show you since I'm using it for some of the private projects that I can't really share with you, but I will just try to describe it to you. So the Sentry is error reporting system hosted in the cloud, and it supports a lot of languages. There are some libraries for almost every popular language, and what it allows you to do, it allows you to log any exceptions or any other custom stuff if you want to this system. So basically, if there is some kind of error, some kind of exception, some other event that you would like to catch, it will go to the centralized system, and then you can look up what has happened there. So this is especially useful for something that is running not on your computer, something that is running in production, since you will probably not go, well, it depends on how your logging is set up and so on and so forth, but this is a great way to discover what has happened, what went wrong with your application running in production. So I started using that for on the free tier, and I just have to say this, that it's really amazing. Like I have some internal satisfaction when I use a tool like this. Doesn't happen often, and this tool is for very specific purpose of error reporting, and it just does it super well. They have a concept called breadcrumbs, and this is also another piece of this framework. And breadcrumbs is also something that you can either manually send or automatically send, and this will be shown to you when there is some other error or exception down the line. All previously collected breadcrumbs will be shown to you on the same error report. So for example, you have some logging set up in your system, okay, and you have logging, like here this event is happening here, then that happened, for example, like info logs or debug logs, stuff like that, and then your application crashed. So then this error of the application crash will be on the system, but there will also in breadcrumbs will be your logs, so like previous events that happened. Super awesome. Let me see, Isomorph, hello there, welcome to the stream. Another news is that I had on previous Monday, I had a presentation for partners about NetConf, RESTConf, and well, it's not my first time talking about this technology stack, and we also had a stream about NetConf and about RESTConf before, but I realized that, first, it's important to talk about this stuff because those are API of network devices in the nearest future, and I do think they will get a lot of attraction soon if they didn't yet. But also kind of like polished all of my talking points about, okay, why would you want to use this in the first place? And all of the stuff we somehow talked about on the stream already before, but this was a great opportunity to kind of like summarize everything in one presentation, in one workshop. Okay, another thing is that I haven't submitted it yet, but I'm going to do it tomorrow. I'm going to submit a session for INOC in Ireland in late November. Hopefully it will get accepted. It's going to be about async.io for the network automation tasks. I will probably change the title a little bit, we will see. I hope that it will get accepted, and then, it means that I will go to Ireland, to Dublin in November. So if you are there, let me know, and we'll get some drinks. Another thing, I met David Barros, and David was original developer of the Napalm, and now he's currently leading the project called Nornir, and Nornir is Python automation framework that I am actually another contributor to the project. He was in Krakow where I live right now, and it was great meeting a person like this in person. He had just awesome guy, and I'm just excited to meet him finally in person. We talked a lot about all of the network automation stuff and all of the current state of network automation in the world, and different projects and stuff. Very awesome person. Yeah, Another thing is that the Michael Kennedy, and Michael Kennedy is host of Talk Python to Me podcast, and he's also the person behind the Talk Python training, developed a course about async IO, and it is now live. So if you go to Talk Python async IO, yeah, this one. So async techniques and examples in Python course. So this course was released, and well, I haven't gone through it yet, but I'm going to do it in the nearest future. I do believe I will finish it until the next stream, and I will share with you what I think. But as far as I know, this is the first course that is out there for Python async IO. So really great news. I do hope that we'll have more async IO blog posts, trainings, books in the future, so that people can learn about it and be less scared. Another thing connected to it, and this one that I just learned just 30 minutes before the stream. So it was a tweet from someone, and the tweet was basically that Python 3 async IO docs were rewritten from scratch. And if you have watched my stream about async IO, you probably know that I was complaining about that. Async IO docs were super bad. I mean, they had everything, but if you read them, you don't understand a thing. Well, depends, right? But in general, they were not really great. So the docs were written from scratch, and if you just type in Google Python async IO docs, you will stumble upon 371 RC1 docs page, and this is like the docs written completely from scratch. Also, I'm going to read them. We'll see if it will happen until the next stream or not, I don't know, but very excited to actually have docs reworked. Another thing, and I tweeted about it yesterday, is I had a call with a friend of mine who is working in one IT company, and he had this idea in mind to build a network automation system. Well, network automation system, but something more than just day zero provisioning. Okay, so not like, oh, like let's create config from templates and then upload it. No, not something like this. His idea was much bigger, is to have actually full control of network configuration state, that it's multi-vendor and stuff like this. So we had a very lengthy call, and we were just discussing potential design of system like this, and I think, well, I was satisfied with kind of like results that he ended up. Hint, there is a lot of yank involved, and I do hope that I will just somehow put this high on my priority list and write the blog post on it, because I do not know. I don't think anyone is doing something like this based on Yang, but this was kind of like my proposed design. If you're like curious more, just ask me some certain questions, and I will share with you my thoughts on that until that blog post will be finished. And I'm very bad with with finishing blog posts, unfortunately. Now, another two interesting stuff is connected to Yank as well. So before my workshop, I was rebuilding the Yank Explorer container, and by default Yank Explorer, the containers that were out there were almost 2 gigabytes unpacked. So I did my best to rewrite the Docker file, and basically now the container for Yank Explorer is 130 megabytes uncompressed and around 40 megabytes compressed. So it's super small now. I'm very excited that I got it done. And yeah, if you would like to use Yank Explorer, this is a great way to use it. So if you go to somewhere like Docker Hubs, no, it's not Cisco, it's Docker I don't remember. Oh, it's hub.docker.com, and then it's tmfigo yank explorer, or not. tmfigo. Yes, this one. So tmfigo yank explorer. So if you just run this command, you will be running the Yank Explorer with size around 140 megabytes, and the compressed size is like 48 megs. Yeah, I have this. Whenever I deploy any kind of containers to production, I try to minimize their size as much as possible. And I will teach you some techniques to do that today in the stream, actually. At least for Python. Okay, and another thing is that I stumbled upon this project called Advanced Network Explorer, and it was developed by Cisco Tail F team, and it's available publicly on the GitHub. So it's Cisco IE repository ANX or ANX. And you can also run it with Docker. So you just git clone and do these two commands and you run it. Let me see if I can actually, I can actually show it to you. And I think I'm going to show it to you. Docker start NETCONF Explorer. Yeah. And if I go to localhost, this, yeah, I will show it to you very briefly because I honestly think this is a great tool. So it's very different to something like Yank Explorer. So it only allows you to interact with the devices that have NetConf running. So here you would put your IP of your device, like 30, and I have Cisco, and then login. And what it does differently, it actually connects via NetConf to the device and downloads every single Yank model out there that is present on the device, and then it presents it in very neat format from my perspective. So I have tried it. I honestly think it's just amazing. I'm not sure if they support like multiple devices at the same time or multiple users. I don't think so actually. But if you just want to explore, Yank for one device at a time, one user, this is just a great way. Like, try it and you will see what I'm talking about. You don't have to know a lot about Yank and a lot about NetConf to explore this tool. Okay, and the last piece is, I must also admit that for one of my projects I migrated to GitLab private repo, and I started using GitLab CI and GitLab Docker registry. And I also have to tell you, their system is just so amazing. Like the whole integration that you have here, Git, you have Docker registry, you have your secrets, you have your CI system, you may have your runners that are running your CI that are private. All of that integration is just goddamn awesome. So if you are looking for a way to have your CI, you want to have your Docker registry, especially if you want to have it private, I strongly encourage you to check out GitLab, because they have unlimited number of private repos. They have registries that you can use. They have the CIs, they have runners. Their integration with all of this different stuff is just second to none. Like from my perspective, GitHub is nowhere close to GitLab from that perspective. So if you're looking for a way to deploy your app, to run tests and all of that stuff, check out GitLab CI. Okay, that's all from all of the different stuff, announcements, news, all the stuff that I wanted to share with you. I did try to make it brief, but I also feel like for some of you it may be interesting to to know the like stuff that is either like happening in my life from the network programmability perspective, or if I discover some new stuff, new projects that you may never heard of, but you may find useful. So that's why the section at the beginning of stream exists. So you can also learn something new, or I can share with you something that I learned new. Okay, so the tool has loaded, and so basically it went to my device under this IP address and downloaded every Yank model out there. And now on the right hand side you can see every single Yank model supported by the device. Now, how to interact with something like this? Well, actually very easy. Well, first of all, you just click on the Yank models that you would like to see. For example, the native model, okay? And on the left hand side you will get some interesting details like what is the XPath for that model, or the namespace, stuff that you actually have to add into your NETCONF request. But you can go even further. You can expand this tree and you can see every single leaf there. So you do this, you see every single leaf. You can now select anything you want. For example, let's say host name. Okay, so I click here on the host name. It shows to me the path as well, stuff like that. But now another interesting piece is that here NetConf console. So you can click on this NetConf console, and if you had the hostname selected, you can either click get, edit config, or edit config merge, or edit config delete. So I will do get, and it builds for me the RPC for NetConf. And now I can just click on the send request, and I get the data via NetConf back, in this case with this host name. What I can also do is that I can change this get to edit config, and it builds for me kind of like a template for the edit config with that host name specified. So now I can do stuff like, okay, so I can change this to, I want to change running config, and I would like to change the host name to something like csr dev stream. Okay, and let me bring up my device in just a second. Okay, so here's my CSR that I'm connected right now. I changed here some data like hostname here, and I just click send request, and it says okay. Now if I go back to device and click enter, you see that my hostname has changed. So I just enjoy working with this tool when I want to explore Yank on network device. Like, man, just great. Guys, just go ahead and try it if you are interested in NetConf Yank. Just a great way to learn the whole thing. Okay. I wish I found out about this tool earlier than I did. Okay, so this is it from all of the new stuff. So let me stop my Docker container here, and let's actually start today's topic, which is, well, Dockerizing Python app, or deploying Python app in Docker, whatever you want to name it. Basically, we will be talking about Docker. Well, we will be talking about containers, we will be talking about Docker, we will be potentially talking about Docker and Compose, and we will see examples how you can convert your Python applications that you are developing into a complete Docker container. So I think for today's example, we are going to use the Django app that we wrote some time ago for the on the stream actually. And you know what, before we will go forward, oh, this is it, netproc stream Django. I honestly barely remember anything that was happening there, but let's go ahead and run this. So you will also maybe see the we'll see how far we will get, but probably what I want to see that how you can actually convert the Django app. So since like it's different than you run Django in development and Django in production. So when you run Django in development, and let me go to the proper repo first. So projects, my public network programmability stream, and source CDN. Actually, you know what? Hold on. Django. No. Okay. So source VN pin activate. Okay. So usually when you're in development, oh, and I'm sorry, I have to go to the proper folder. So I have to go to the netproc stream Django. Isomorph is saying in the chat, I just used Docker for the first time recently and it's pretty neat. Usually I do my stuff in VMs, but it was super slick. Absolutely. Yeah, like if you have ever deployed any kind of application, any kind of script that you wrote somewhere that is not your computer, and then at some point you discover Docker, I guarantee that you will not fall back to something else. Like, it's just, from my perspective, the best way to deploy your app. You'll see why. So, okay, so here's my Django app. And what is going on? I don't see a folder here. No, it's actually fine. Okay, so I do Python manage py run server. Okay. Okay, and my server is up and running. Yeah. So if I go there, so I kind of remind you what the Django app was. So we had the Django app. You log in. Well, we were trying to develop web application that allows you to interact with your network devices somehow. And I told you the reason we are doing that is actually it's pretty slick, because you can write your like network automation system, blah blah blah, but you know, in general it will be CLI based. But usually your users do not want to go to some server and run something on the CLI. Your users would like to have some kind of web GUI with some kind of form, with some kind of data that you can go to the page and, you know, click some buttons there in the GUI and, you know, the magic is happening. So for this, that stream, and I think it was like 7 streams ago, this application, we have like a main page like this, which says hello stream, this is Dmitry, and then there is device table, and this device table is actually referring to our database that is SQLite in this case, which has 2 devices. You know, we just added 2 devices there, CSRDEV and CSR3, with their IP addresses and credentials, but in table we only show the name and the IP address. Now you can click on the device like CSRDEV, and it goes to the device and fetches every single interface out there and some statistics about the interface. In this case, it fetches like every interface description, and if it's enabled and if it's up or not. And then there is button, a very ugly button, but it's still a button, which allows you to switch on and off interface. Okay, so for example, my loopback right now is it's not enabled, so I can click on switch button, and it will take some time obviously because I think it logs in via SSH. I didn't do any NETCONF there. It logs into the device and just shuts down that loopback. So it will take some time. We'll see. Let's make sure that it's working, because dockerizing non-working application just makes 0 sense. Okay, so you see that now my loopback is enabled and it's up. And if I go to my device and I say show up interface brief, you can see that my loopback is indeed up. Okay. So this was our Django application that we wrote. Now, okay, let's kind of like walk slowly, like what are containers, why would you want to do them, and then later how to do them, okay? Before doing that, I do have to check one thing. I have to check if I don't have any containers running, which I don't. Okay. Good. Okay, so what are containers? And I'm not going to give you some like formal definition. If you want formal, just go to Wikipedia. Okay, I will just share with you my understanding. So containers is basically an environment that that isolates what is called user space, but shares the kernel space. So think about something like virtual machine. Okay, so you have, let's say, your Windows machine and you're running like a Linux container. What is that? So, and how virtual machine is working. So you have a hypervisor. This is some kind of software that can either sit in your operating system or can sit directly on the bare metal that is managing your virtual machines. And virtual machine by itself is an isolated environment where you have isolated kernel and you have isolated user space. So everything is isolated. So that's why you can run Linux machine on Windows machine, okay? Linux virtual machine on Windows machine. So on somewhere like on Windows, you would install like a hypervisor, like VMware, like VirtualBox, whatever, and then you run your virtual machine. So everything that is happening inside of the virtual machine is isolated from everything that's happening on what is called host. Okay, so when we have virtual machines, we have host and guest. So guest is your virtual machine and host is your system where your hypervisor is running. Okay, so everything that is happening inside the virtual machine has nothing to do with your host. So you can't really like change your admin setting, your sudo your root settings direct from within virtual machine for your Windows machine. That said, hypervisors allow you to like map some directories and stuff. So for example, you can map some kind of like your home directory from your Windows machine directly into Linux. So that is doable. So there is just what is called mounting, basically mounting of some volumes. Now containers are containers are very similar but yet different. Containers are also providing some kind of isolation, but it's not 100% isolation. Your all of your software, like your libraries, your application itself is separate. Okay, all of that is running in what is called user space, but your kernel is shared. Okay, so you share resources with your host. Well, in virtual machine case, you're also sharing that, by the way. But you're also sharing like system calls. Whenever you have to allocate memory, you always go directly through your host, okay? Because you share kernel. So it's less isolation. So it also means technically less security. But everything in the user space. Is isolated. Okay. So what is the result of this? How it's like? What is the consequence of those differences between virtual machines? Well, containers are super lightweight. They are much more lightweight than virtual machines. They just run faster. There is less overhead because you don't have separate kernel for your virtual machine. And most of the time, that is enough for you. I mean, you don't really need another copy of your kernel or like another kernel, because your application, doesn't care that much about it. It cares about its own its own dependencies. It cares about its own code. It cares about like the whole environment behind that, but it doesn't really care about kernel most of the time. It just needs, you know, someone to manage that for it. So this resulted in I want to say revolution, but some people will disagree in the whole software development world. Basically, you had a way to create this container with your application, which you knew would run the same on different environments. Okay, so previously, if you wanted to have this kind of like consistency between, like, you know, you run on stage server, on your production server, in your dev environment, you would have to create a virtual machine. Usually people didn't really bother because, you know, every virtual machine is like a couple of gigabytes of space. You have the whole like Ubuntu or Debian or whatever that is. It's kind of like slow. It takes time to boot up. It takes time to like restart. All of that stuff. So, but probably I think like the main thing is that like this overhead of managing virtual machines, this overhead of the space as well. So a lot of people didn't really do that. Instead, they were running their applications directly on the servers without any kind of isolation. But what it means is that depending on what is like even the version of operating system on the servers that you're running and what was previously installed there, you know, you essentially have different environments. And what this often resulted into is stuff like, oh, but it works on my machine. Okay, I don't see any problem. It works on my machine just fine. But you know, somewhere on that production server, there was just some script that is, I don't know, was installing some other dependency which, you know, completely screwed up everything for your application. Happens all the time. So Docker is a lightweight way to provide isolation for your application. It allows you to have a consistency between your different like environments. Okay, so you know, you run this application in your container on one server, on another server, on third server, and it behaves the same. You know, you don't care about what is installed on that server other than just Docker. Okay, so you have their, you know, Ansible installed with something else. Okay, fine. Docker doesn't care about it because it provides user space isolation. So it really changed the way how applications are deployed. Probably someone since like 4 years ago, I think there was a boom on doing everything in containers. And you know, this trend is still there. I learned about containers, I think around, when was it? I think it was around it's almost 2 years ago. This was my first experience with containers. For Cisco Live presentation that I was given, I think it's actually 1.5 years. We were trying to set up workshop for, you know, like 8 computers, and the time between the different workshops like 15 minutes. Okay, so during 15 minutes, the previous presenter has to get rid of his code on the workshop machines, and there were 8 of them, and we had to deploy all of our code and make it, you know, up and running. It's actually a very time pressuring environment, you know, like, and you also, if you are a presenter, you know, you have to prepare your own laptop, you know, plug it in, put the mic on. So you really like have to set up everything for your 8 computers, like, I don't know, 7 minutes really out of those 15. So we were looking, you know, in ways to do it faster. We had some stuff in virtual machines, some stuff in like code we had in Docker. And when a friend of mine, Kevin Cools, taught me that, I just instantly realized the power and like why would I want to do it? You know, like it was literally we had like one shell script which was just starting our containers and our virtual routers on the devices, and that's it. Okay, so like basically I went to every single machine and I ran one script and everything was up and running, my code, my CSR router, all of that stuff. And this was the point where I realized the power of it. You know, otherwise, you know, you had to have a bunch of scripts that installed directly on your Mac something, and maybe someone already installed something beforehand. Not really great, but this kind of isolation in Docker really helped. And since then, I started learning more about Docker, and now every single application that I deploy somehow in production runs in Docker, unless there are some kind of reasons that I can't do it. You know, so there are a couple of things that changed the software development practice as well, with Docker gaining more and more popularity. So there are a couple of, and there's some ideology of Docker as well. So one of them is that the containers themselves are not persistent. Okay, so what this really means, you should be able to delete container and start a new one, and that's it. Okay, so you kind of like have a snapshot of your application, you deploy it in Docker, but then, you know, when the lifetime of that application is done, you're just deleting container. You are not trying to upgrade your application directly inside Docker. You are upgrading your Docker container itself. So you create basically a new container. This is how you upgrade your application. So you have to kind of like be okay and do your software development in such a way that will allow you to do that. This is the first piece. Second piece, a Docker ideology is run one process per container. So usually applications, for example, like web server, have so many different components. For example, Django app. So you have your code that is running Django itself. You have your code that, you have your Nginx frontend, so which will serve as the reverse proxy. You have something like Redis or memcached to cache your stuff. You have your database, something like Postgres. Okay, you may have something like Celery to run long tasks. So like around 5 pieces, you know, in a simple web application, 5 different things. So in Docker ideology, you would need to run all of those in separate containers. So if you have 5 different services, you have to run 5 different containers. It's not like strict requirement. You can actually run it. There is no like nothing stopping you, but it's what is considered best practice. If you want to run containers, you have to be okay with one process per container. What is also changed is the way different services were developed. So the idea of microservices appeared much earlier, but I think it became very popular during the rise of the Docker containers. So the idea of microservices is that you have very small pieces of applications that are doing some particular task, and then you have an API interface for that application which allows other application to talk to them. Okay, so microservices and API like go hand in hand. So for example, you have some kind of like authentication, and it's some kind of, I don't know, LDAP authentication or something like this. You may develop a separate service that just handling authentication and authorization, and it exposes an API for other applications to work with it. Okay, so the whole like microservices just went boom when boom. It's not a good sentence, not a good English from this person. So it just gained a lot of traction when the Docker became popular too. So you try to make your you try to get rid of one big software, one big application. You separate it into different things that are called microservices, and then you are exposing an API on this microservices so that other microservices can work with that. There is a question in the chat. So I want to make an app which accesses the website behind the hood and uses the details input in the front end to log in and then scrape the website. I have already tried pure Java in Android Studio. Then I tried Selenium and Kiwi. Neither seem to work. Can you give any suggestions? Thanks. Oh, and yeah, and there is another subscription. Higo. Thank you very much for subscription. I really appreciate it. So going back to question from to the question from Vilja and 234. So an app that accesses a website behind the hood and uses the details input in the front end to log in the scraped website. Okay, so well, it depends. This particular question has nothing to do with Docker, but that's fine. I'm okay to answer any kind of question on the stream. So I had similar tasks a couple of times. So if you want to scrape some website, it really depends how the website is built. Most of the more or less modern websites are using API on the backend. So they have backend which exposes an API endpoints, and your front end which goes to your website via API. And if this is the case, then it's very trivial to replicate that in in any kind of programming language. Okay, like I usually use Python and request library, very easy. How can you identify if your backend uses an API if it's not documented? Usually you go to some website, and I'm thinking about some good example. Okay, I am going to do something like this. So, for example, dcloud, and I will have to log in. Okay, just give me a second. Okay, so for example, here is the website and I would like to scrape it, right? Usually the first things that you would do, you would go to developer tools and the network tab, and then you will click here on persist logs and click on XHR, and then you try to browse the website. So for example, I go to catalog, and then you try to basically click on every single thing here and investigate what is going on. For example, if I click here, and good indication that there is API if there is in the URL API. So I clicked here and it says here that it does get on this URL API catalog published get, and then if you click on the response, you get some kind of response. And if you dig through this is basically every single demo that is available on dcloud. You can get via API. So basically, if you see something like XHR and maybe like type JSON or XML, and maybe there is a link in the maybe there is a mention in API, go to developer tools and try to understand how the interaction between front end and back end is going on. So Usually the most painful piece is figuring out authentication, but once you are past that, doing everything else is usually quite straightforward. So if you're trying to work with undocumented API, this is the way to go. So then, you use any kind of library and programming language that you know to just do HTTP requests. Super easy. Now, not every website uses API on the backend. For example, these websites that we built on the Django stream, we didn't build API because for the first web development stream I wanted to keep it super simple, so it has no API. What do you do then? Well, then you use a library, something like Beautiful Soap in Python, but there are some other libraries. You still have to figure out the authentication piece, but usually it's quite straightforward. Usually you have you go to your web page, there is a login form, and there is some kind of button like submit or something. So you also will use something like developer tools to see what is sent in the form and what is the response. And then again, using some kind of HTTP library, you can actually build a form. Well, actually not to build a form, but replicate the post request in your code by providing a specific data. And that's pretty much it. And then you can do the same stuff. But since you don't have API, it means that you don't get the raw data from your backend. It means that you have to parse a HTML page. So for parsing, you would use something called Beautiful Soap in Python, for example. And this is a library which can help you navigate through your whole HTML code, HTML page. It has some learning curve, so you will definitely want to refer to docs, but it's doable within a couple of evenings. I also had to do that for some of the websites that I was trying to build an application. Now there is a last thing, and so some websites use heavy JavaScript, especially for login and for data. So there are some websites that everything is built on JavaScript. So even if you kind of go to some page, it will use JavaScript to fetch the data. It will fetch the data, but using JavaScript. So I had one occurrence of the system like this, and then it's super painful. So if this is the case, then you would need to use something like Selenium with the browser. And the main reason why is because what Selenium allows you to do, it allows you to couple your Python, for example, or something else. It's multi-programming language with a browser, with real Chrome browser, for example. So which will actually run the JavaScript for you. Because if you are using something like request library in Python, it will not run JavaScript for you. So for those very hard cases, you would need to use something like Selenium with a real browser, maybe in headless mode, to do it. I actually have one project where I do that, so it's doable. And there's a comment: I tried replicating post request, but form is sent with cookies and unique IDs. Yeah. So well, it depends. I can't, really every website is different, but it's still doable. So you go to your login page, you try to understand where the ID is coming from, or how the cookie is set, or whatever it is. So usually in that case you will use something like request session, which persists cookie between different requests. So you try to understand how you populate these fields and in the form and all of that stuff, and then you try to do it in code. Usually it's quite painful, it takes a lot of time, but it's definitely doable. So, if you will give me some directions of the stream and you'll ask me privately, I will probably help you out how exactly to do that. Okay, but that's a very good question. I have to deal with this kind of stuff all the time because there is not many documented API out there, and usually when it's documented, it's really bad as well. So whenever I have to interact with some other systems that I didn't write, usually like I am stuck with using the developer tools, understanding like every single request, what is going on, how do I replicate it, and so on and so forth. Okay, great question, thank you. Okay, so I think we stopped at the point where like why would you want to run Docker? And I think I discussed that in a lot of details, well, for intro, I would say. So basically Docker containers allow you to build this kind of like a snapshot and of your application and of your dependencies, which, and then container basically will run the same in different environments, which is super cool. I told you that the Docker mantra is one process per container. I also told you that containers in general are non-persistent. Now, this is actually quite important piece. Now, if you're saying that your container is not persistent, then you're having a problem when you want to store something on file system, especially if you'd like to have a database, okay? Like, well, if container is not persistent, where do you store your data? You having a database not to lose the data in the first place. So because of that, there are a couple of things that you may do. One of them is called volumes. You can map any kind of directory from your file system into the Docker container. There is another thing called named volumes. So basically you kind of like create some kind of like name for this mapping, and then you can reuse this named volume in different containers. Okay. That said, still, like for something like database, it actually doesn't feel right, I would say. So there is actually a lot of debate, like if you should run your database in Docker container or not. I still don't have a good answer, probably due to lack of experience in that area. So I tried both seem to work, but I believe that something like database you would want to run probably on your host directly, and yeah, probably not in Docker. It kind of like becomes a little bit more pain in the ass to interact with your database through Docker, and you don't gain a lot. You also still have some kind of overhead from containers as well, so I'm not sure this is like great idea, but it's doable. So running like something like Postgres in separate container is doable. Probably we will do something like this on the stream today. Yeah. What else? Well, yeah, but for something like, some kind of file, if you want to have some like persistency but not database like, you can just do volume mapping. This is what I do a lot. You map some kind of folder with some kind of data that you would like to store. Okay, good. So let's see. There are two ways to run. Now there are more than two ways to run, but in general, if you kind of like want to use just Docker, there are like two main ways to run Docker. One way is you can build your Docker container yourself and then run it. And this is what you would do if you're developing something. If you are a user though, you can just run you can download the container from a public space, something like Docker Hub, and just run it. Okay. Now we will see how to build Docker container, but probably a little bit later. The first thing that I want to do is to show you how would you just run container as a user. And because of this kind of like separation and isolation, what this allows you to do, it allows you to test a lot of applications and run them without kind of like caring how to install them. For example, if you were watching my streams before, I ran Netbox, which is IPAM system in Docker. I didn't want to care about how to install it. I just ran one command and I had it up and running. At the beginning of this stream, we were running NetConf Explorer, also in Docker. Since I also don't want to care like how to install a Java application, and it's actually a Java application. So this kind of stuff is like, you just run the command and you have your app up and running. Awesome. So probably how I'm going to show it to you, I'm going to take one of my repos for Cisco Live where I had Jupyter and we'll walk through that. So first I'm going to show you how to run it. Okay, so basically for Cisco Live, for one of my presentations, I built a Docker container which had a Jupyter notebook with running some of the packages. We'll see what packages in just a moment, but for now let's imagine you are just a user of Docker. Okay, so what I did, I built a container and I published it on Docker Hub. I published it here. Jupyter NetDevOps Py 3. Okay, and it says if you want to download this container, use command docker run docker pull this. So let's go ahead and try some of this stuff. Now let's look on this command a little bit more, on this docker run command. Here I'm doing docker pull separately, but you don't necessarily have to do it. So in general you build your container and you publish it somewhere on Docker registry. It can be private registry, it can be public registry like Docker Hub. By default, it will try to look for the image on the public Docker Hub registry. Now, every image is identified with image name. Basically, this part on the left, dmfigl/Jupyter NetDevOps, is image name, and part on the right is called tag. So it's basically some kind of identifier of the specific iteration of the image. And usually you can actually rebuild container with the same tag and publish it, so you have a newer version of the same image and tag. Let's take a look, for example, on Docker Hub Python repo. Okay, so Docker Hub Python, and those are the tags that are available. So what they do, for every single version of the Python, they built a container using different base images. We will talk about that also, but they have a bunch of tags, and some of them are very static, like 366 stretch, but they also have tag called 36. What this means is that once you have a new version in this branch, like 367, they will rebuild container with 36 stretch tag and publish it as 36. So as a user, you can identify if you like to run very specific image or broader image in this case. So you can either run like 366 stretch, or you can run 36, or you can don't even care about that and just run Python latest image, so it will just run the latest image. Really up to you. Usually you want to have that image for your production as stable as possible, but probably not like exact the same version. So I usually use the main major release. So for example, in Python I would use 3.6 Alpine and 3.6 Alpine, 3.7 and 3.6 Alpine, so that when there is a new version in the same branch of Python, I can still kind of like don't change anything, just pull the latest version of that container. Yeah, so what is a typical example? Well, usually first you just install Docker and Docker daemon. You can also install Docker on Mac and on Windows as well. Be careful though if you have some hypervisors like up and running. I guess I think there's still a problem that you can't run Docker daemon and your hypervisor at the same time. So careful with that, like like VirtualBox and Docker at the same time. But I also tried it and it's I didn't have problems. So once you install it, and on Mac and on Windows, you will actually install what is called Docker machine in the background, which is a virtual machine with Linux. Very lightweight, because most of the containers are built for the Linux, so you actually need Linux kernel in order to run your containers. So this is the case for Docker for Mac and Docker for Windows. They actually install small virtual machine and run it, but you just don't see it, and then they run their containers inside that virtual machine. It's called Docker machine. On Linux you just run Docker daemon directly on the Linux. So I already have it up and running. You can see here I have my Docker is running. It's just a daemon. How to check if you can run any container? Basically you say docker run, and the default container is called hello world. So what this command is going to do is going to pull the hello world container. It will try to pull hello world container from public repo. So if I put here in the search, I have this image hello world, and there are some tags, blah blah blah, but it will download this image. It will set, first it looks on the local cache and sees if it has already the image, and by default if you don't provide a tag, which is column and tag, it will use the tag latest. So it sees that I don't have this I don't have this image locally called hello world latest, so I'm going to try downloading it from the internet, from Docker Hub. But if I already had this image, oh, and by the way, you see that this container, the only thing it does, it just prints some message, and that's pretty much it. Okay, so it pulled it and then run it. So then I can say, now if I run it again, you will see that there will be no more line like this, pulling blah blah blah, because it will find it locally. You see that there is we are not pulling this anymore. Okay, so whenever you pull any container or you run it, you will cache it locally. This also means that you have to be careful when you rerun the container with the same tag that you already have in the cache. You may run the old version. So if you want to force getting the newer version, you say docker pull and the name of the container with the tag. So this will just try to re-download the container. Okay, so this container just prints some message. Let's run something else. Let's run, I usually do a lot of Python. So I do Python 3, docker run Python 3 Alpine. And I'm going to also now provide one additional argument called --rm. So -rm means that I am going to delete an actual container once it finished running. Because by default, if you just do docker run, once the container is done and it's finished, you'll still have that container but in stop state saved, so it will take space. Most of the time you don't want to do that. Not always, but most of the time you don't want to have that. Because if I say ps -a, if I say ps -a, I still see this hello world containers up here. They are taking space, they're in stopped state. I can actually restart them if I want to, but I'm not going to. So docker ps -a will show all of the start and stopped containers. And let me do this. So if I do just docker ps, it will show me containers that are up and running right now, and none of them are up and running right now. Okay, so these two containers are still take space. So if you forgot to do -rm, you'll have to remove those manually using docker rm. Actually, the new syntax, there is a little bit newer syntax. It's called docker container and rm, and then rm. So now if I do docker ps -a, I don't have those hello world containers anymore. Now there are two different terms. One of them is called containers and one of them is called image. So image is this snapshot, this in this kind of like frozen state, well, snapshot basically of the code. Container is something that is built from the image. It's an instance of an image. Okay, you may run multiple versions, multiple containers from the same image, and a lot of times it actually makes a lot of sense. For example, in something like web application, you have one code which you package in one image, but then you run multiple containers either on one machine or separate machines because you would like to load balance between those. Very common task. So you may run the same container, you may run the same image but in different containers easily. This is why there is this kind of separation, image and container. Okay, good. So docker ps shows running containers, docker ps -a shows all of the running and stopped containers. And here, by the way, I have my Selenium container in stop state because every so often I need it, so then I just do docker start. I have my Young Explorer container also in stop state and NETCONF Explorer container in stop state. Okay, so let's go ahead and do what I wanted to do. So I wanted to do docker run -rm and let's say Python 3 and Alpine. So there are a couple of very popular base images for the Docker containers. One of them is obviously Ubuntu. So as a base image for your other containers, you use Ubuntu. Another very popular choice is called is Debian, and another one which is probably the most popular base image right now is called Alpine. So Alpine is also variation of Linux, but it's super lightweight. If I do docker pull Alpine, and I will say docker images and grab Alpine, the Alpine image is 4 megs uncompressed. It's super lightweight. Basically the only thing, well, it has Linux, well, it has stuff like VI and it has shell, but all of other applications are absent there. So this is usually the best choice for your production environment. It's the main reason why that your containers will be small based on this image. Obviously, if you run, let's try also docker pull Debian. Okay. Okay, let's grab on the images. So Debian. So Debian by default takes 100 megs. Ubuntu will take even more. Okay, by default, without installing anything custom. So that's why Alpine is the best choice most of the time for your production environment. Another interesting piece is that they have also, repositories with build packages, and they update it all the time with like almost latest versions of the packages. So literally you can install almost anything from their repo. I think the choice is even wider than what you can install on something like Ubuntu. And actually, let's go ahead and do this. So if I say docker run -rm and -it, so here's a new switch, -it. So it's basically for interactive. So whenever you're in your code, you actually need some kind of interaction where you type something on std-in, you use this argument it. So it will allocate gosh, how it's called, tty, and it will allow you to do interactive input. So docker run -rm to delete container and -it to interact this container. I'll say Alpine, and it brings me to the shell. Okay, and if basically this is just /bin/sh. Okay, so if I say bin/sh, yeah, so I'm running bin/sh, but if I do stuff like git, it's not here, bash, not here, and stuff like this. Okay, so by default it's not here, but you can install in similar way like you install packages on like CentOS or Ubuntu. Here's the package manager, is called apk, and you say apk add, and here I usually use this argument called no cache. And this is also quite important for your containers, that ideally when you are trying to build your container, you would like to have it as small as possible. But if you install packages by default in Python, in your Ubuntu, Debian, whatever, all of them are cached somewhere locally, so that if you try to run the command again, they are going to be pulled locally. But since you are trying to build small container, you don't need anything in the cache. Okay, you want to pull everything directly from your internet during your build time, and yeah, to reduce the size of the container. That's why I try to tend to use this no cache argument. And let's say I am just going to install git, and I'm going to install the bash, okay, and maybe curl as well. Okay, it installs those super fast, and now I have git, so I can do git clone something, I can do curl, I can do bash if I want to have bash. Easy. A lot of packages there as well. So just to reiterate, the command was apk add no cache, and then you specify packages that you would like to install. Cool. Of course, it doesn't have Python as well, because for Macs only, no Python. Okay, cool. So yeah, curl, bash, Python. Well, we didn't install Python, but yeah, this is how you install packages in Alpine. And you can run some shell script, so echo hello stream, for example, stuff like this. Cool. And folks, let me know if you have any questions, something maybe is not clear, I would be gladly stop and help you out. Okay, so for now I will exit Alpine. Now this is good, but for stuff like, usually your applications are written in some kind of programming language, okay? So I usually use Python. So usually as a base image for that, I use Python Alpine container, which is basically Alpine, where on top of Alpine they compile a version of Python and then delete all of other stuff that is not relevant and just leave Python and Alpine. That's pretty much it. So this is my usual choice as a base image. So in order to run something like this, I will also use arguments -rm and minus, well, I don't remember if I have to use, I don't think I need to use IT here, but let's try. So I'm going to use Python and I will just use 3.7. Okay, 3.7 Alpine. Okay. So it says, okay, there is no image like this. Actually, I think I should be able, I need to specify IT. Yeah. I forgot to specify IT, and this is what happened. It downloaded the image and it ran it. By default, it runs the command Python, but since I didn't allocate the TTY and I didn't put interactive, it didn't allow me to interact with this, so it just closed the image right after downloading it. So I run it again. You see, nothing happens. So yeah, I need to specify -IT. So I do this, and now you can see that I end up in Python interpreter, in Python 3.7 interpreter, and here is just my Python prompt. Okay, so I can say, like, I want to do something more than hello world, but when you're trying to think of something, nothing comes to your mind. Let's say technology is called Yank, and we'll say print f technology is amazing but quite complex. Okay. What did I do? Oh, okay. Yeah. Okay, and it says Yank is amazing but quite complex. So this is just Python interpreter. Okay. So again, just to reiterate, what is this image? This is official image from Python repo, where you have Alpine as a base image, and then you have Python 3.7 installed. Everything else was deleted from that image. Okay. So right now I will exit it. Now you can already see some use cases of stuff like this, and I use it also all the time. Like I would like to run interpreter, but for some reason I don't have specific version of interpreter installed locally. So I just run docker run rmit python 2.7 Alpine, for example. And I have Python 2.7 interpreter already there. I don't care like how do I install it, what dependencies are there. I don't care about any of those. I just run container with my application, which is in this case Python. Okay. Now another piece of that, okay, that is good, but when I build my application, I want to run my application, I don't want to run Python interpreter. So if you run this, it always brings up interpreter. So how do you actually run your app? Okay, so usually, again, for kind of like some kind of exploring purposes, as the last argument for docker run command, you can provide the commands that you would like to run. And in this case, I will run command called sh or shell. So instead of running Python command, which is default one, I'm going to run shell command. Now I end up in shell. Now if I run Python, I will end up in Python 3.7, but if I exit from it, I don't end up in my system. I still am in the Docker container. So you can still see that there is no Git, there is no curl, there is no bash, there is no nano, stuff like that. So I can actually now go ahead and install it. Let's say git or curl in the image with Python and Alpine, and now I have Python and Alpine. Right now I have Alpine, Python, and 2 other packages. So if I do something like -sh/, I can see that my whole container with Python installed takes 100 megs. 100 megs was the the image size of Debian without anything, you know. So it's quite an improvement. So if I do Docker images, grab Python, my images here, Python 2.7 Alpine takes 60 megs. Python 3.7 Alpine takes 78 megs. Super small. Okay. Yeah, so my default image is usually 3.6 minus Alpine or 3.7 Alpine, depends on what exactly I'm doing. And almost for any application now you can run it with Docker. For example, let's go to Netbox, Netbox Docker. And if I go somewhere like Docker Compose YAML, let me see. It's not what I expected here. Let's see, maybe here. Yeah. So here is a Netbox which was built by someone and published also on public repo. Damn, this is not correct. I mean, well, this is correct, but it's not what I want. Let me see. Well, stuff like Young Explorer, for example, right? So let me go to my repo back. Here. So I built a container for Young Explorer, and now you can just go ahead and run it. Okay. Now let's actually walk through this a little bit, and let me explain what all this stuff means. Now, there are some additional parts. There is this part is image name without tag, so by default it will use tag latest, but this part I didn't cover yet. So --name is the name of the container that you are going to assign for the container built from this image. By default you just get assigned some random hash number. So, but if you want, you can, you know, provide a specific name. Now this piece is also quite important. This piece is port mapping. Okay, so if you run Docker container and it's some server that is listening on some port, by default you can only access it from, you can either access it from containers that are on the same network as the Docker container, or from the container itself. You can access that port, but you can't access that port from your host machine. Okay, you can't. So when you run something like this, like Young Explorer, which exposes a web port, you can't go to localhost 8088 without specifying this command, because it's listening inside of the container, but your host machine is not listening on that port. So if you need host machine to listen on some port, you will need to provide what is called port mapping. So with this -p argument, you provide the port on the host system, and then you provide a port that this container is listening on, and yeah, and then you can have this mapping. Now this -d says I would like to run this in the background. So you can see that now when I use this command docker run -rm -it blah 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 sh, it brought to me like to the front the like shell and all of that stuff, when I run hello world container, it actually showed me the output directly on my CLI, but very often for something like a web server, you just want to run it in the background. Okay, so you don't need to see anything that is going on, because if you exit the shell, you still would like to have your container running if you exit SSH, for example. So this is why you use argument -d, so it just runs in the background. Okay. Now another piece, let's go back to my DevNet repo, and there is another piece here. So let's kind of like walk through this example. So first it's going to pull this image, DMFIGO Jupyter NetDevOps Clues 2018. It's going to assign a name for the container spawned from this image called DevNet 3627. I'm going to run it with RM, so when it's stopped, you're going to delete container. It's going to run it with IT, so that you can see it on the you will get all of the output directly on your when you run it. And then there is one additional argument that I didn't discuss before. It's called -v. So the -v is mapping volumes. So you're saying that in the current directory /Jupyter, I would like to map it inside of the container. It will be at /Jupyter. Okay, let's actually go ahead and run this, and I will show it to you in a second. Let me check if there are no containers running. There are no. Okay, so and because I don't have Jupyter, yeah, before doing that, I'm going to actually go to my repo, my public DevNet 3627. Yeah, it's here. So here I have my repo cloned. Now, one of the things here is that I have Jupyter folder in this directory. Okay, let's go ahead and run this. It says I can't find the image, so I'm going to download it from internet. Excuse me, folks. So this container, when I built it, I don't think I was targeting the smallest possible size, but that's fine. So in this case, I have my Jupyter, and Jupyter is basically a Python running in the web browser, plus Markdown and plus some cool formatting. This is how we usually run all of the DevNet workshops, so that people can just walk through the notebook and just click run, and all the stuff is done basically for you. Now, I see logs directly from the Jupyter, but I can also access my Jupyter server now using localhost 58888. Now, look at this. And I'm going to close this Django app. I don't need it. But here's something quite important. You see that the command that I ran was -v, and it says from current folder /Jupyter, map it to /Jupyter on the inside of the Docker container. So there is a way to run any kind of command on the running container. So docker ps, here's my container, and I'm going to say the form docker exec DevNet 3627, and I'm going to say lsla /. And this is going to show to me the file system from / inside of the container. And you can see that it has a folder called Jupyter. If I go to /Jupyter, it shows to me the stuff inside of the container in /Jupyter folder. However, on my local machine, it is the /Jupyter in the folder in the current folder. Okay, so basically I take one directory and map it to another path inside of the Docker container. Since it's two-way mapping, anything that I create there will be reflected on my file system and vice versa. For example, you can see here those are the files, okay, and those are the files that are seen by the Docker container. Now I go ahead here and I say cd Jupyter, and I will touch some file, stream livestream txt. Okay, so I touched some file on my local system. Now go ahead here, and this file is seen in the inside of the Docker container. Okay, if I do different thing, if I create a file inside of the Docker container, another useless file txt 1 2 3 and save. If I now do lsla, I see here this file, another user's file on my file system. So this is like two-way mapping. You can specify one-way mapping if you want to like read only, and sometimes you want to do that if you know that your Docker container is not supposed to change the file. So I'm going to ram those two files. I'm going to go to slash, and you see those both of those files are gone now. Okay. I don't think we are going to see named volumes today. It's kind of a little bit advanced. I do hope that I gave you some idea about Docker, and you even as a user you can understand the benefit of the Docker. Is that, you know, all of these new applications, in order to try them or run them, you don't need to install them manually. You can just run the Docker container, which is downloaded from the public place. So yeah, hopefully this was useful for you. Let's look at the time. So right now the stream is going for 1 hour, around 40 minutes. Okay, we still have time. Perfect. So now we are going to move to another part. How, as a developer, you build a container, and then another piece, how do you build the minimal size of the container? So our idea will be to dockerize this application. So let's go ahead and start doing that. So in order to build a Docker container, you have to provide what is called Docker file. Yeah, let's see. So I want to create a new file, and I would like to add the Docker file. Usually you add 2 Docker files. You add the development and the production. So this, I mean, obviously everyone is doing it differently, but this is how I usually do. I have 2 files, Docker file -dev and Docker file. The reason why that, during development you have a little bit different workflow. Usually you test something, you install, uninstall, all of that stuff, and there is a lot of room for error. So you may need this kind of different things. You may need stuff like live reload. You may need to stuff like whenever you change your code locally, it's already reflected in a Docker container. In production, you don't have that need. You know that this code was already tested and then it's working, so you just deploy the code and you run it there. So the use cases are a little bit different. That's why I usually have 2 Docker files, one for development, one for the production. So I'm thinking right now, probably I will create it. We'll see how it goes. Development one. Okay, so usually what I do, I just copy those Docker files from my other projects, because I spent like literally tens of hours to understand every single piece in Docker file and how you build that, what are the cornerstones and all this. So once I got it up and running the way I wanted to, for most of my Python applications I just copied more or less the same and change a couple of things and then test them. So this is what I'm going to do as well. So I'm going to copy example of my Docker file for development and for production, and then we are well, I'm going to walk you through the pieces and then we are going to adapt it to our project here. So let me do this. I need to create a new window. I have to take the file from one of my projects, so bear with me here. And I'm going to copy it from my Flask application. So Docker file dev. Yeah, this is dev. And I need to copy the same for production. Okay. Yeah. Okay, let's copy that. We will not need a couple of pieces, so I'm going to delete them right now. Yeah, this looks good to me. Some of the stuff here is kind of useless. Yeah, let me kind of like look through it in a second, because there is some stuff like for development that actually are not really needed and make it more complex. So I guess I can delete this part. And yeah, I think this is pretty much it. I don't think we have entry point. So yeah, we'll see. Okay. Docker file dev. Yeah, looks good. Okay, so before doing that, I'm going to add one additional piece. I'm going to add PyProject toml and PyProject the log. Since I already talked to you about the poetry, and this is application management and dependency management for Python, and I almost fully migrated for all of my new projects. I just realized that I didn't for Django, for this app that we built, so I'm going to do it right now. Now before doing that though, I have to kind of like look through the code. What are the libraries that I use? Okay, so I use Django, I use Napalm, I use NetConf, and this is pretty much it, right? So Django, Napalm, NetConf. Yeah, I guess so. Okay, good. So let's very quickly create a poetry project. Yeah, so we need poetry, need package name netproc string Django. You know what? Before doing that, let's do it again. So package name netproc stream Django version whatever. awesome network controller. Author me, license MIT, compatible Python versions. I don't recall which Python versions I was using for this project, but let's have 3.6. Let's have 3.6. And would you like to declare dependencies? No, I don't need those. And yes, I confirm generation. So once it's done, I have my PyProject toml. So now I have to deactivate here the virtual environment. I would like to say what is my Python version, Python 3.6. Now I'm going to say Python minus m venv.venv. So I'm creating a virtual environment here in this folder, and then I have to add my dependencies. So I say poetry add napalm netmico in Django, and this will take some time. Okay, napalm netmico Django. It's actually quite important that I walk you through like this process here, since you will understand the Docker file easily. In general, Docker file is just sequence of commands that you have to do to be able to go from the base image to the image with your application. Okay, so everything is installed. Okay, so once it's installed, I have also log file with specific application, library versions. Now, before we go forward though, I have to double check that my app is still running. So I'm going to do it by using poetry run manage py run server. Oh yes, because it's poetry run python py run server. It should be exactly the same as it was before. So I go to localhost 800. Yeah, so it's still up and running, still my database is intact. Perfect, good, awesome. So yeah, this is good. And I'm going to stop this Jupyter. It has, I mean, we are exploring Docker not Jupyter today, so I don't need this anymore. Yeah. Okay, this is useless, but this is useful. Okay, so the same thing. Now let's start looking on the Docker files that I copied, and you will understand what I'm trying to do here. Now for development, I tried using the Alpine, but I also exploring recently the Debian Slim version. I don't remember exact reason why I did that, but there was some reason. Not to confuse you, I'm going to convert this to Alpine a little bit, and yeah, we should be good. Now you will not need this part because this will be a little bit later. We will not need this part. Okay, so let me see. So we have first the from statement from the base image, then label who is responsible for writing this Docker file, me, and now you using run command to basically specify your shell scripts that should be run in order to get to your application state. Now copy statement says, okay, I'm going to copy this file to the Docker container, and then run again is part of the shell script. And then this CMD is quite important. CMD says if you run your Docker container without specifying the last argument, which was a command that you want to run, like we did Python and then shell. If you don't do that, this is the command that is going to be used. And you have to provide the command in this syntax where you provide a list of arguments. Okay, now let's kind of like walk through what this particular file does. We have to modify it a little bit because it's kind of like not correct anymore. So first we will just add our dependencies that we need, and in order to be able to install our application, we are using Poetry. So the only thing I really need is Poetry installed. So this is what this kind of like piece is going to do. So apk add, and I will add no cache. And in order to install Poetry, and their page says you have to run this command. So you need to use curl, download it from the GitHub, and then pipe it through Python, and then you will run and install Poetry. However, Alpine image doesn't have curl, so we have to add curl. So I add curl, and then I say my next command is going to be curl minus SSL, and you have to, like, if you're curious about those, you have to read about man curl and stuff. So we do that, and then I don't need this anymore for development, for example. So I need Python 3 Alpine, apk add no cache curl, and you know what, guys, I'm going to change it to slim because it will be a little bit easier. And if you start doing that, don't go directly to Alpine because you will see. The main problem is that Python is not a single binary, and there are packages in Python that depend on C extensions and C libraries, like cryptography, for example. This is actually one of the reasons why pip install cryptography doesn't really work on Windows. You have to download the binary for for a cryptography library somewhere already compiled and built. So some of the packages in Python can be installed, well, they require C dependencies. And those C dependencies usually have to be installed, usually separately. So yeah, the problem here is that the Alpine is very, very slim base image, doesn't have any dependencies. So then you will have to, for every your single Python package that uses C dependencies, you have to figure out alternatives for those packages in Alpine. And for most of them, those are present in APK, but you still have to figure out those names, because you can't say, like, if you do apt-get libcurl2 or -dev in Ubuntu, you can't transform this to apk add libcurl2 dev in Alpine. Its package name may be different. So that's why for if you kind of like start, use probably fat image first, since it already has a bunch of dependencies. You may probably be able to copy some commands directly from the guides, like you go to cryptography and says, oh, here are dependencies, here are for Ubuntu, run this command, and you would run like sudo apt-get install blah blah blah. So this is just my recommendation. When you're starting, don't care too much about the size. Care about the size when you're ready to go to production, then you will have to actually do a lot of work to figure it out, or use my examples. Probably one example that I actually have shared of one of the slimmest containers that I have is for Yank Explorer. So if you go to, let's say, GitHub, dmfigo, github.com, dmfigo Yank Explorer. Here is my Docker file for that Yank Explorer container. This is my production production Docker file, you see it has a lot of stuff, a lot of weird commands, potentially some tweaks. It's quite complex, you see, but this is what you have to do if you want to build very small container, and usually for production you want to. Okay, let's go back to our tab here. So what I'm doing here, so I'm running up at curl, so I'm installing curl, and I'm here installing poetry. Now I'm copying the two files, but honestly I just need one, and I actually thinking that probably I actually need them. Yeah, I need them. So I need to copy the PyProject toml and PyProject log. To be honest, I just need log file, but I would just have two. And then I run this command. I'm saying python -m venv.venv. So this I'm creating virtual environment. And then I'm saying poetry install, no def, no interaction. So what this basically says, it takes log file, looks for all non-development packages, because toml file have production dependencies and development dependencies. So it takes all of the dependencies here, and without asking you any question on the CLI, it installs those automatically from the log file. So once you do that, my default command is going to be poetry run, and here I have to change this a little bit. So we saw that command was python manage py run server. So we are almost there. Let me kind of like walk through it again. A curl, PyProject. Yeah. Now, there are a couple of pieces that you probably have noticed. We didn't copy our code yet. We didn't copy code of our Django app. And man, damn, it's kind of incorrect. Yeah. Yeah, I'm sorry guys, I will have to change this a little bit. So I have to add a new folder called I will not be able to do it. I will add it here. Say netprog stream Django. Yeah, so now, and I'm going to take all of this stuff except the Docker files, and yeah, and I'm going to move all of that inside of this nested folder. But Docker file I will leave directly in the root. Yeah, virtual environment has a lot of stuff. You guys very silent today. Oh, there was actually some comment in the chat. I think you need to use apt-get for Slim version. You know what? Max, you are absolutely right. You are absolutely right. So I will have to, yeah, since I'm using here Slim version, I have to use apt-get update, and I have to say apt-get install curl. Yeah, correct, because this is based on Debian. Okay, so let's have it like this. This changes a little bit. Let me see. So if I go to my network stream Django again, and I have to, let me double check that this still works. Okay, and let me check if my website is still opening. Yeah, we should, you know what, double check that node cache. Yeah, okay, it's up and running. So usually you would like to put Docker file, probably not in the mix of your Python code, but somewhere, well, it depends. I could actually leave it like that, but I'm thinking. if I did a stupid mistake or it's actually fine. You know what? I think I need to do this again. I'm thinking now, why did I put it to like different level? Oh, yeah, I know why. Okay, so since ideally I would want to like copy one nested folder easy with my app. Yeah, this is why I did it. Okay, yeah. This will be a little bit easier. Otherwise, if it's on the same level as my Python code and all this stuff, then it becomes quite a mess actually. I have to change this a little bit. So here I have to say NETCONF Django PyProject TOML and PyProject log. Yeah, and this part is it. But as I told you, we copied the files local from the local system TOML and log, but we didn't copy the actual code of application, right? So I'm going to show you in a second how we are going to deal with that. So I'm going to stop this. Now I need to go to one directory above, and here we are building our container. So the way you build container is using docker build command. So you say docker, well, hold on, docker file dev. Okay, so you say docker build, and because we have docker file dev, which is default name is docker file. If I have non-default name, I have to put -f argument, and I say docker file dev dot says that the file should be, well, what is called docker context is in the same folder. I'm not going to go into details what is docker context. Right now it's not really relevant for the first stream. Now I'm doing that, and now I have to put a tag on this container. So -t, and I will name it the same way. I will name it NETCONF Django latest. Okay, now stuff is happening, and empty line continuation. What did I do wrong here? Well, maybe -y. Yeah, by the way, yeah, here is one of the mistakes. Now, if you think about a lot of like shell scripts, some of them asking you questions like yes or no. And I had here upget update without -y. So it was asking me on the prompt yn, but I was not able to answer. So usually things like this have some kind of switches which do not ask you anything, and you confirm that you agree with everything. And also I found here that I have here an extra slash here, which I'm going to delete. Okay, let's go ahead and run this. Okay, now it's happening. It's downloading the latest version of packages, blah blah blah. It still didn't work out. So, oh, you know what, folks? I'm sorry. -y should be here on apt-get install, not on apt-get update. Okay, let's save this and run this again. Now, while it's being run, I'm going to tell you something. And I'm going to, even though I'm not going to walk you through right now, I think I would just keep it right here so you can see the whole process at least once. Honestly, it's just a bunch of shell scripts. There is not a lot of magic here. So I'm here right now installing Poetry. I can see it here. This is Poetry stuff. It says Poetry installed. Now there is another step, another step, another step. And now Poetry is installing the dependencies from the log file. Okay, so this also will take like a couple minutes. So let me walk you through what is happening. Every single line is what is called layer in Docker, and every layer is cached. okay? And the more layers, like every layer actually adds a little bit of additional overhead. This is one piece. And second piece, that whenever you have some kind of change in Docker file here, like on this layer, which will be 1, 2, 3, 4, 5, 6 on layer 6, if you have some kind of change in command here and you rerun build, it will actually just do this one step, okay? And I broke it somehow. Oh no, it's actually, it was my copy stuff. It says here successfully built. Okay, so step 7.7, build. Okay, so whenever you change, and I'm actually not sure what is here, it's some log file, whatever. So whenever you change command on any layer, all previous layers are cached. So you don't need to rerun. You don't need to rerun these commands here. You'll just rerun, because you have cached layer up until this, and you have a change here. You will just take this cached layer and then run this command on top of it. So let me give you an example. So if I do here touch useless txt, okay, and so I changed layer 6, okay, so layers from 1 to 5 should be the same, so I should not be able to, well, it should not run the apt-get again and all this stuff. So let's run this. You see here it says using cache, using cache, using cache, using cache, and now on layer 6, now it reruns this command again, because this is a layer that has a change command. Pretty slick, huh? Let me see what was in the chat. Oh, install -y, yeah. I figured that part out. Okay, cool. Now another interesting piece is that for production containers, usually you want to have everything in as little layers as possible, so that to make your container be of less size. This is why you usually don't have like one run statement per every command like you have in shell file. You use one big run statement like this, you know, I have this and this and this. For production, you will even change some order of this, so that you don't have these two layers are separate. You will actually have those two layers as one. Okay, so it's actually run. Now, let me do this. How to run it? And before I run it as Django, I'm going to do something else. So I'm going to say docker run it for interactive shell and --rm to delete it once we are done. And then by default, if I run this is the command that is going to be run. But for this example, I don't want that to be run. I just want to command shell to be run. So I do this, and I am now in shell of my container that I built. Now, if I did everything right, this useless txt should be in the root of this container. And you can see here, it's right here. I also here in the root have PyProject toml and PyProject log files, because they are coming from here. But I don't have here the directory with the code. Okay, I don't have the directory with my code, because I have to provide it specifically, well, explicitly. So let me exit, and now I'm going to actually run this container with the code, and I will try to make it sure that everything works the same way it was working before Docker. So there are a couple of pieces that we have to do, and I'm also going to open a Scratch file here, because it will actually be quite a long command. So file, new Scratch file, txt, no, it will be what, shell or bash? Where is bash? Here's bash. Okay, so let me copy this command and we are going to modify it a little. So first of all, since it's a development environment, it's usually okay to map your code directory directly in the container. Okay, so not this one. So I need to map this netproc stream Django directly into the container. Let me see. I may need to change this a little bit. Yeah, I have to change my Docker file a little bit, sorry folks. So I'm also going to do this. I'm going to say mkdir netproc stream Django. And then if I want to run this, I'm going to say netproc stream Django. Well, actually, no. I'm going to do this. I'm going to say workdir netproc stream Django, and then this part is left as it was. Okay, so I have to rebuild my container. Okay. Yeah, you see, again I'm using cache. Probably I should have deleted this, that's useless. And you know what? I'm sorry folks, I'm also going to change it. Since I'm again in development, I don't care really about the size of the container. I am going to move these two commands as a... No, I think I can leave it like this. So I was thinking like to move this to a separate statement again, because I right now don't care about the size of the container. But you know, I don't see a lot of sense. Okay, so let it run, because again it will take a couple of minutes. We have some work to do here. So my Scratch file, we have to map our directory with the code to the container first. Oh, and that's pretty much it. Okay, together with the database in this case, so that we don't have to repopulate our database again. So our statement is going to look like this. We can still leave ITRM if you want to. For development it's fine. The image is this. We will not use shell, but we have to map a directory, and here we'll say current directory, netproc stream Django is going to be mapped as netproc stream Django. So now the content of this directory will be as a /netproc stream Django inside of the container, and then I run this container image, and then it will run command by default, which is in this Docker file, which will be poetry run Python manage py run server. I'm thinking if I forgot anything. I don't think I did, and this looks good to me. Yeah. Okay. So yeah, I think this should work. Now there's an additional piece is that I didn't map the port, so I will not be able, even if it's going to run okay, I will not be able to see the web application from my host machine. So I have to provide an argument p 8000 to 8000, and yeah, I think this is pretty much it here. We'll see. Yeah, okay. So let's go ahead and run this. P minus V. Okay. Couldn't import Django. Make sure it's installed and available on your Python path. Oh wow. Okay. What is going on here? I think I may know what that is. .env. Yeah, there is one additional piece that I have to do. I have that docker ignore file, and docker ignore file says what are the files that should be excluded. Man, I don't remember if this works if you... Damn it, I don't remember this. I don't remember. I don't think it does, but I don't remember if it impacts the -e option. I don't think it does, so then I will have to rework this a little bit more. So here I will say .vnv, but I don't think it means anything. And you know what? Let me open documentation for docker ignore. Yeah, I think docker ignore only influences what you have in copy statement. Yeah, so this is actually kind of not good. I think I will need to move this .env directory back to root. Yeah, I think I may do that. Yeah, I think this should be fine. So I do this. And what else I need to move? Well, I need to move this by project lock and toml file as well. Yeah. Okay. So I'm thinking if I should rebuild the container or not, and I think I do. I don't remember why, but let's redo this. No, it's actually... Oh, okay, yeah, I have to redo it because my copy is in a different place. So docker file def, I have to do this. Poetry run Python manage py. Okay. And also, let me check that I have Django. Okay, I have Django here. Let me go napalm Python. Looks good to me. Okay, so we built a container. Now let me again look through this. So I am mapping the directory with the code there, and then I say my work here is going to be that. Yeah, okay. So let's run this. Okay, so now it's actually running, and it says starting development server, recruit server. Okay, so this seems to be working fine. Now let's go ahead and go to the website. So again, localhost 8000, and it doesn't work. Damn, what did I forget? Oh, I think I know what I did forget. Isomorph, thank you very much for following. So I think I forgot to say that we are listening on port 8000. Yes. Docker file listen. Oh, expose. Expose instruction informs Docker that the container listens on the specified network ports at runtime. You can specify whether a port listens on TCP or UTP or uses default TCP if the protocol is not specified. The expose instruction doesn't publish the port. It functions as a type of documentation. No, I don't think this is it. Oh, okay, yeah, I remember now. The Django run server command allows you access only from localhost. So Django run server from 000. Yeah. Okay. Blah blah blah. I think it's just. Yeah, I think this is it. So because, yeah, you can only access the port 8000 if you run this Django run server from within container as a local host. But from when you are doing it from your host machine, it's not local host anymore. It's actually remote like communication. So I have to actually change my Docker file a little bit, and you know, yeah, this should be alright. I can also say that I can expose port 8000, but as you saw, it's actually just documentation, so it doesn't tell anything. Well, it doesn't do anything really, as far as I know. Okay. We have to rebuild our container. You see it went super fast because we changed only 2 last instructions. Now I run this again. It should say 0008,000, and now I go to my website here, run it, and boom, it's up and running, and it's running in Docker. Okay, so yeah, the same stuff. I click here and I should get my interfaces. So yeah, let's wait to make sure that, okay, this works. Perfect. So right now we dockerized our first app, but this is still development environment. It will be different if you are doing it for production. The main reason why that if you do Docker images, grab network stream, you can see here that this image is 290 megabytes. It's not like super big, especially compared to some like Java applications and some other stuff. I don't know, where you need compiler and I don't know, all of the stuff. So it's not that big, but it's still quite big, especially considering that Alpine itself takes 5 megs. Python with Alpine is 80 megs. So everything else is what we installed. So we can optimize this further. And specifically for Python applications, I did a lot of research and I tried so many different things. And you know, I took a lot of advice from different people. And I finally, I think, found a configuration that works for me most of the time. And I'm happy with it. And I'm happy with the size of a container. So this is what we are going to explore next, and probably the last thing for today. I don't think we are going to do Docker Compose today. Yeah, I don't think we'll be able to do that. It's already 2 hours 30 minutes that we are running the stream. So yeah, let's try to build a production container from this. And yeah, we'll wrap up for today. So what is going to be the difference? So let me take the Docker file that I have for my other application for production, and we are going to kind of like walk through it a little bit and then change what is needed to be changed, and then do it. So one of the things obviously is that we have to copy this command at the very end. It just is logical. We will be running the same command. And again, it's kind of like not exactly prod, because remember, if you're running Django in production, you have to do a bit of work. You will not use built-in server, but you will actually use Nginx, you will use GUnicorn, you will use all of the stuff, yada yada yada. I don't think I'm up for it today, so maybe some next time. Right now we will just to see what is the difference between production container and development container. Okay, so again, here's my example, and you see that I moved my dependencies, Python dependencies, at the very top. And the reason why that I would like to have one big run command, so that it's just one layer, so it takes less space. Now another couple of pieces that I'm going to delete this .env file. We don't have it. We don't have entry point script as well. But this copy file is what we did by using volumes mapping. So when we did volumes mapping for our development environment, we wanted to have any kind of changes in our code directly reflected on the running container. In this case, our code will be actually part of the container itself. We are not going to map it anymore. We are actually going to copy the whole code directly into the container, and it's going to be part of the snapshot. So this is probably the main difference. Another difference is that we would like to compress the number of commands to as little number as possible. So instead of 2 run commands that are separate, we are using 1 run command, and there are also some differences in the run command itself too. So let's do it step by step. So first we copy our netproc_stream Django, and I will still need work_dir different, so I can have it as a next statement. Okay. Work_dir netproc_stream Django copy, yeah, okay, and I think that's pretty much it. Yeah. So let me walk you through other differences here. What is so different about this, well, than previous one? By the way, so here when we are running 2 separate run commands, those are going to be cached in separate layers. And there is one other important rule, that the next layer of the Docker container can't be less in size than previous. So you will still, every new layer is previous layer plus something else. So if in some later run command you do some kind of aram, araf, or whatever it is, it has no impact on the size of the image. That's why it's important that if you install something and you install something extra, that you delete it as part of the same layer. Super important. This is why this run command becomes super complex. So let's walk through it one by one. So for Alpine, first of all, I'm using the feature called no cache, so that I don't save anything in cache, and I'm also using a feature called virtual. So virtual allows you to put all your packages as part of the one group, and then you can uninstall this group easily. So I'm putting these what is called build dependencies, and in those I have build base, GCC, libff, idef, and OpenSSL-def and curl as well. Why I'm doing that? Well, the reason why that, as I told you, some of Python applications requires you to have C extensions installed. So And in order to install these C extensions, you need to have proper C libraries installed. For example, if you need to install a cryptography library, you need to have compiler, and you need to have associated libraries like OpenSSL-dev and libFFI-dev as well. So those are what are called build dependencies. You don't need them once you have installed, once you compiled and built your cryptography package. You don't need them anymore. You don't need to run them. You don't need them to run your Django app. That's why I am marking them as virtual, well, not as virtual, as build apps. So then I'm doing the same kind of stuff with Poetry. I'm installing Poetry, creating my virtual environment. Now here's another difference. I'm having here this environmental variable pip_no_cache_dir. So this one says, okay, don't cache any kind of Python dependencies locally. Always get them from the internet. So I'm doing that. Now here is another piece that I copied from someone when I was doing research. I'm sorry, I don't remember your name, but whoever you are, you did a great job with doing that. So what this does, it finds all of the PYC and PYO files and all tests and test files and delete them. And it also does the following. It says it creates a environmental variable called rundeps, where it uses this scanlf command. It looks on the what are the runtime dependencies of the packages that you installed on Python packages that you installed. So it's looking on /user local and /.venv. What are the runtime dependencies of the stuff that you're running? So it looks for those and adds them to this environmental variable rundeps. So then the next step, what it's doing is deleting all of the, well, it's actually installing all of the rundeps as a separate group and deleting all the build apps. And then as the last step, I also figure out that sometimes there are some cached files here in /root.cache. I'm also deleting those. So since all of this done is one layer, you actually reduce the space. If this part and this part were done in different stages, you would not save space, because as I told you, every next layer is a previous layer plus something on top of it. So that's why it's important to have it as part of the one big command. Then we copy our code. We say that our work directory will be this, and then we run the same command. So other than this, it's the same. You can see the example of kind of like this Docker files that I encourage you to use for your applications. I use it successfully for at least 5 different projects already in production. So if you're curious about that, go to my GitHub repo, Young Explorer, Docker file, and here is an example that I have for Young Explorer. Okay, so let's go ahead and build this container. So we are going to build the same in container name, and but I'm going to just say that this is release 0.1. Now I also either I can specify that I'm specifying the -f Docker file, or I can delete it because a Docker file is default name. Okay, so let's go ahead and build that. Yeah, everything looks good to me. Okay, so it will also take some time. So guys, this is a good point for you to ask questions while we are waiting for dependencies to be installed, if you have any. So also before we had a container which was almost 300 megs. Okay, we are installing Poetry and then we are continuing. and I just realized that I can make it even less. For this application, I actually have 0 run dependencies. I don't think cryptography library requires any kind of runtime dependencies, so I could actually remove these 2 steps and we could save a little bit more space if we wanted to. I think so. I haven't tried. I must tell you though that writing proper Docker files, and I broke something. Yeah. Yeah, about that. Collecting Pinnacle. Yes. For Pinnacle, I think I have to. Okay, first let me delete this. And yeah, so this is the stuff that you would actually stumble upon when you're trying to build your container very small. So no matching distribution, lib, cf. I'm wondering why it's not compiling though. Pip install Pinnacle. Matching distribution found for lib. Damn, this is bothering me. Let's do something. Yeah, so this is actually like, you know, if you're DevOps guy in your company, this is probably the stuff that you have to do, trying to figure out how to write the best Docker file possible. Sometimes it's fun and sometimes this is just nuts. Let's do Python 3.6 initial. Okay, usually like when I stumble upon problems like this, what I'm trying to do, I'm almost copy pasting stuff like this. And I will need a log file too. Okay, Python is version 3.6. Let's do pip install. What was the library? I think CFR. No, it was Pinnacle. Pinnacle 1.3 error is a falling output. Oh wow. Okay. Okay, here is a version of Pinnacle. There is version 1.3.0. And couldn't find the version that satisfies the requirements. CFI. Okay, so it says there is no version CFFY pip install. Well, I see this and it's right here. libcfi. It says version 1.4.1. So if I say pip install libpynacle 130. Let's see if this will work. We are very close to the finish line here, guys. I hope this is not a problem with poetry itself. I really hope it's not. Interesting, this one worked just fine. So it said pip install Pynacle 130 and then it just installed it. But poetry fails though. Do I have poetry already installed? Yeah, I have poetry installed. Yeah. So I will need a log file. So let's say the PyProject log. Okay. So I have my log file, and now if I say poetry install, and you know what, guys? Just for some reason, my Siri got activated. What's wrong with this? I haven't said hi Siri. Okay, now it's talking to me. Okay, poetry. So poetry install no def, no interaction. So yes, Python vnf. There is also some debate about if you have to create virtual environment inside Docker or not. Honestly, you don't really have to, but also it feels like it doesn't really hurt to have it isolated from system packages, even though there are not many that are installed with Python. I always have mixed feelings about this. Right now I'm using this just to use one less command, because otherwise I would need to use special command in poetry to configure that, so I don't want to do that. So lsla, so I should have .vn file. So now I should be able to say poetry install no def, no interaction. Oh, I actually need PyProject on PyProject. Okay, go. That error message really bothers me. Like, considering that I have dependencies and I tried installing this Pinnacle library before and it was just fine. Excuse me, folks. Just couldn't find function libxml installed. What is going on here? Now it failed on another command, on the command lxml. But here there is compiling error, so I should be able to fix that. XML version. Yeah, libxml. I need libxml. libxml alpine. So yeah, this usually when you see something like this, then you say, okay, what is the library that I have to install? So usually something like this. So we go back to our Docker file and we add here another dependency. libxml-def. Okay, so libxml is definitely part of the NC client. So okay, and you know what I'm going to do? I'm going to add another process here. Okay, let's go ahead and run this again. Meanwhile, we can say apk add no cache libxml-def and rerun our stuff. And it's still failing where it's failing now. Command gcc file libxml. Yeah, I think I need both libxml-def and libxml2. So let's see. Okay, more problems. Okay, libxl XLT. Yeah, this is how it looks like. The whole thing. Okay, one more try. What's wrong now? I think I also need a dev version of this. Jesus Christ. So there are some things here that are just bothering me very much. like I ran the same command and then I'm going to delete this part. Okay. Oh, we will have stream shorter than usual. Need to reset. Yeah, right. Okay. This actually looks good here. We were able to go through this cryptography. Not sure why it's stuck here though. Okay, it still failed. Couldn't find a version that satisfies the requirement. Okay. You know what? I'm a little bit exhausted, so I do not have a lot of mental power to troubleshoot this properly, and usually it takes a lot of time, like yeah, usually it takes a lot of time. So what I'm going to do instead, so I'm going to do the following. So poetry run pip phrase are requirement 60. I know it's not perfect. Cat requirement 60. Okay, I have that. So instead I'm going to fall back to just requirement 60. I don't need curl anymore. I don't need curl here. I don't need to really to create a virtual environment. So I can say here pip install -r no cache -r requirements txt, and we will also delete this. Okay, so let's go ahead and run this. By the way, it's very interesting that this succeeded, but in my Docker file it didn't. Okay, let's see. Yeah, so the ones that have to be compiled actually take a lot of time to install. Wow, it really takes forever. That's why it's good that all of this stuff is handled by your CI CD, and you don't have to do like look on this on the stream route that just takes forever. And hopefully I didn't make any mistake here. Need the Docker file. Know what? I'm going to talk a little bit about something else. I can't just, leave the stream hanging for... Oh, and the second I started talking, it just went through. So, even though we will not we'll be covering like Kubernetes or Docker Compose on the stream, well, first of all, it doesn't mean that in the future we will not. Maybe at some point we will actually try to run something like Minikube for Kubernetes. I actually have never tried running Kubernetes before. I obviously did Docker Compose, but no, not Kubernetes. So, but in general, even stuff like Docker Compose, Kubernetes, some other systems, the general idea that those are a way to deploy Docker containers. And in general, there are when you run your service, you have a number of containers that are depend on each other. Okay, so for example, if you have a web app like Django, we already talked about, you have your app with a code which will be run in something like JUnicorn. You have Nginx, you have Celery, you have Redis, you have Postgres, and so many different other services. Now the question is, how do you run them all in tandem? Maybe also some services depend on each other. For example, if you run Celery, before you run Celery, first your Redis should be up and running, or your RabbitMQ should be up and running. Before you run Django, probably you would like to have your database up and running first, so that something doesn't crash. So stuff like this. Also the same. Well, it depends, but yeah. So there are these dependencies. Now, also, how do you make your Docker containers talk to each other, right? What if they have some shared data between each other, like shared file system data? How do you handle that? So this is the stuff where for development you would use something like Docker Compose, and this is what I use for my projects, both in development and production. Since I don't have scaling, I don't need to run like a full-blown container deployment system like Kubernetes. So I just run everywhere in Docker Compose. Even my blog, by the way, runs in Docker Compose. It's basically another YAML file which allows you to declaratively define your containers and how they should run, and what are the policies if you would like to restart them, and stuff like this. Basically, it's a way to use Docker CLI in kind of like declarative file and bundle stuff together. Kubernetes, it just takes it one step further. It's just full-blown container management system, container hosting system, I would say, where you can easily deploy containers, you can easily scale number of containers, where you can do like rolling upgrade and all this stuff. So whenever you have some kind of like scaling where you run more than one instance of something, you'd probably have to think about something like Kubernetes. For my own purposes, I don't need Kubernetes, as I told you, just I don't have any kind of scaling project, that you need millions of users or millions of connections per second, so I don't use Kubernetes. Yeah, by the way, while I was talking, and you see that my container was successfully built. Now let's do this. First, I'm going to show you the size. So if I do docker images, grep and netproc, you can see that I have this 0.1 version tag, 140 megs, and then the another one is 290. So you see that the difference here is quite significant. It's almost 2 times, okay? The one that I built with my production Docker file. So let's go ahead and try to run this. And you know what? I actually made a mistake here. Since I deleted poetry from here, I can't do this anymore like this. Let me see. Can I just run Python? Yeah, I can run just Python. So I will have to rebuild it. Let me go ahead and do this. So we'll rebuild it. Okay, and now we will run almost the same command like we did before. What is going on here? I can exit. Let me see. Docker run it no. Okay, this, except I don't mount the volume anymore with my code, because this code is already part of the image itself. Okay, so here I should specify the proper tag, and this is pretty much it. So now I go ahead and run this. Okay, it started up out just fine. So let's go ahead and go to localhost again, and you can see that I'm able to access it. So probably another thing that you would want for something like a web server, instead of running it with IT, this particular container makes zero sense to run with IT, because there is no interaction on the CLI. So instead of running it with IT, I would just put with -d in daemon mode, and then you would be able to get these logs anyway. Actually, you know what? Let's go ahead and try it. So I will still leave a RAM, and I will add -d for daemon. Okay, so now you see that my prompt is returned, but now I have this container running docker ps, this one right there. And if you would like, and you know what, let's reload it. You see that it's still up and running. Now maybe you would like, oh, and there is some problem, but I don't want to solve it right now. Oh, I actually know what happened here. So what happened here is that I got rid of runtime dependencies, and now cryptography fails when it's trying to access the device. So I should have left those run deps there untouched, which I didn't. So I'm not going to redo this. I'm quite exhausted right now, but you see that this container is up and running. And what you can do is there is also command docker logs, where you specify docker logs and container ID or container name. You do that, and you can see all the logs on stdout and stdr there. So yeah, actually libssl, no such file or directory. Yeah, so this is how you can do alternatively. So now if you would like to stop this container, so let's do this again. I will say docker stop and then ID of the container, and since I had --rm flag, it's going to be deleted as well. Yeah, so let me see the chat. I don't see anything in the chat, so yeah, it was quite silent today, but that's all right. I hope you yeah, let me do a summary first. Yeah, so on this stream I showed to you what is Docker, what are containers, why would you want to put your applications in containers. I showed you how to use containers if you are a user, but also we saw how you can build a container yourself from your application, both development and production container. You know, it's not like you can build Docker container like, you know, just in 10 minutes and that's all. Especially if you're trying to build a production container, usually you have to do all these different tests and see which library you need and which library you are missing, because you also want to keep your size very concise. You don't want to install 1 gigabyte of dependencies. Okay, so that's why, you know, building writing correct Docker files, well, takes some practice and requires some experience. But also, even if you still will not be able to do it like within 10 minutes, especially for production. For development, it's quite easy to do. So yeah, I also briefly described what is Docker Compose and what is Kubernetes and why would you want to take a look at those. We haven't built like our Docker Compose file at this stream. I'm not sure we are going to cover this in the newest weeks. I think I will select some other topic, but this doesn't mean that we will not come back to topics like Kubernetes in the future, especially considering that Kubernetes will be something new for me, like I haven't touched it, and probably it will be a very interesting experience, but also it's very niche since it doesn't have anything to do with network programmability per se, but it's more software development. But you know, we'll see. Probably maybe, you know, in a couple of months or in the months, I don't know. I do have some interesting topics for the next time. So with that, and as I see there are no questions in the chat, I would like to thank you very much for joining me today. I wish you an easy working week, and yeah, all the best to you guys. Take care. See you next week. Bye.